remember that bone tissue is coming from mesoderm, and then that mesoderm could become muscle, or it could become mesenchymal cells, right? Those are the cells that could become any kind of connective tissue. And so at some point, these guys get the signal to become either chondroblasts, right, which are going to go on to form cartilage, or osteoblasts, which are going to go on to form bone right there, right? So that lineage splits at that point. So chondroblast, remember chondro means cartilage. And when we're talking about bone formation, there's two major types. One of them is called endochondral bone formation, and then the other one's called intramembranous bone formation. So endochondral, chondro, you should be thinking cartilage, right? And we'll see why in a second. Inside the womb, fetus right here. And remember, when you're looking at an x-ray, bone tissue will show up and everything in between won't. Like, so if this is cartilage right here, it's not going to show up. The brain at this point does not have those big plates in its skull yet. So if you looked at any section of your skull right here, you'd have that compact bone on the outside, a spongy bone on the inside. Right? And then surrounding it, you'd have that periosteum. Remember, periosteum was that dense, regular connective tissue, or dense, irregular connective tissue, right? That's covering the bone right there. So you have that fibrous layer. Remember what that looks like? Dense, regular, all that collagen covering the bone on both sides, right? So you got dense, irregular, compact bone, spongy bone, compact bone, dense, irregular. For any bone, right? This just happens to be a piece of your skull bone. We also talked a little bit about those sutures and how they form, how you got that fibrous connection in between the two bone plates right there, that when you're a fetus or an infant, right, those haven't fully formed yet. So instead of this strict bony attachment, you have a fibrous layer that'll just going to continue to expand before it fully closes. Right, so that fibrous layer is kind of what we're talking about with this right over here as the skull is growing, right? Because that's how it kind of starts out. So these bones, these bony plates of your head, these flat bones of your head are going to form by this process called intramembranous ossification. That is, these plates of fetal bone, right, are going to grow out and form your skull bones and facial bones. And again, I'm not really going to get into the details here, but just imagine that this was the periosteum on the outside, this was the bone, this is how it starts. You have all this as embryonic mesenchymal tissue right here, this fibrous membrane. And in the center, it starts to what's called ossify. That is, it starts to turn to bone in the middle about that. And that happens because these mesenchyme cells in the middle, they start to condense. That is, grow very dense, and they start to become osteoblasts. They turn into osteoblasts. What do osteoblasts do? They secrete bone matrix. That the embryonic connective tissue condenses, those mesenchyme cells change into osteoblasts. Osteoblasts secrete matrix, which then becomes calcified, and then that whole tissue becomes bone. That is the process that is happening in the head for the most part, so that these plates are going to grow out and eventually grow out to form all your, mostly your cranial bones right there. So that's intramembranous ossification happening for the most part in your skull right here. And then for the rest of the body, for most of the rest of your body right here, there's going to be a different process right here. You see all this blue stuff here represents cartilage, right? So this process is called endochondral ossification. You don't have to know this, hence the red, but all that condensation of mesenchyme occurs in your growing limbs, right? It's growing along the long axis of your limbs. The mesenchyme is condensing. Instead of becoming osteoblasts, those bone cells, they're going to become chondroblasts. Okay, they're going to become chondroblasts. So basically, they're going to become cartilage instead of bone. So you're going to have this kind of structure in the fetal limbs, these cartilage models, kind of like a rubber dog bone in those babies' arms, well, the fetus's arms right there, right? And so those are your first sort of bone structures, and those bone models, those cartilage models, are going to be replaced over time by bone tissue. And so the cartilage cells don't turn into bone strictly. Basically, the cartilage cells in the middle here get choked off from a blood supply. They die. Once they die, bone cells and blood vessels move into this spot right here and replace those dying cartilage cells. This happens in the middle, and then it happens in the end plate right here. Right? So the bone is going to replace those cartilage models over time. You'll see that this is a kid's skeleton right here. You can see the spaces in between right here, over here, and in between. All the spaces in between here would represent cartilage that's not showing up on the x-ray. And then here's the adult bone with all those filled in spaces. So this is called interstitial growth because the bones are growing in length, right? And so what happens is as the bone grows, as the process is occurring, the cartilage model is being replaced by bone. And eventually, what all you're left with at the very end, after you've done maturing, is the last remnants right here are your articular cartilage right here. That's why you have articular cartilage right at the ends of your bone, because you started out all cartilage, right? So you're starting off like this. When you're growing, this is maybe when you're first born, like this, you have that end cartilage, but you also have what's called an epiphyseal growth plate, this strip of cartilage right here. And so the cells are going to be growing on this side, and they're going to be dying on this side. So you get this growth on this side, death on this side, so the bones keep growing lengthwise. So they're just going to grow. They're going to be adding on this side and being replaced by bone on this side, so that strip stays the same length as so they're just going to grow. They're going to be adding on this side and being replaced by bone on this side, so that strip stays the same length as the bone elongates. All right, you don't really have to know the details of that, but basically that's how the bone grows in length, right, through this epiphyseal growth plate, and that's how the growth occurs there. So in the end, all you're left with, again, is that articular cartilage at the tips of your bones. This epiphyseal line right there, you might see this in the anatomical neck of the humerus right here. You'll see it in any bone. You'll see this line. It's called the epiphyseal line. That's that last bit of growth plate after you're done growing. All right, so that's how bone grows in length. And just a fun note here, when you're doing an archaeological dig and you find a bunch of bones and you're wondering, hey, are these just small people or were they children? Right? You could look at the bones right here and look at those epiphyseal lines right there. So right here, this is the tibia. You can see this division right here. This is where cartilage was. The bone remains, the cartilage kind of dies off. But you can see that epiphyseal line. This indicates that this is the bones from a child, right? So that's your bone growth in length, right? And then there's also this thing called oppositional growth. This is the bone growing wider, right? Obviously, as the bones grow in length, they're also getting thicker. And so generally what happens is bone cells, those osteoblasts, are laying down new tissue on the outside of the bone, and it's just growing thicker. The medullary cavity is getting eaten away at the same time, and that's why this cavity remains the same size, right? So you go from this to this, and that's all you have to know about that. If you're interested, you could look up this on YouTube. They have some cool videos. You could watch how like all these lamella and the osteons form. Basically, this wave of bone growth occurs over the blood vessels, right? So if this was this layer of the periosteum right here in blue, you can see how it envelops this bone vessel. And then that, as the bone grows, it kind of gets deeper and deeper into the tissue right there. That's just a fun fact. I won't ask you about that, but that's how those structures grow as the bone growth happens. All right, so that's appositional bone growth. And so the bone is growing in length and it's growing in width until about 21 years old or so, give or take a few years, and then you're set for life, right? Your bones are pretty much as long as they were and around as thick as they were. All right, so that's bone development and growth.